Welcome, everyone. Welcome to Philly B-Sides. That was loud. You are at MFA. It's 2017, and you're still doing it wrong. If you're here for anything other than multi-factor authentication, you thought MFA stood for something else, you should probably go to the Russian talk, because we're talking a lot about multi-factor authentication. I'm Chris Salerno. That's Dan Astor.
Hello.
I like mine better. Anyway, I am a director at Security Risk Advisors, and some of you may know me as not a defensive guy, and instead as an offensive guy, but I am here to tell you and make the official announcement for everybody who's confused. I am 100% defense now. I lead our 24/7 CyberSOC at Security Risk Advisors. Dan?
I'm Dan Astor. I'm a senior consultant on our technical assessments team. I perform penetration testing, red teaming, stuff like that. So focus is offense.
All right, we've got an agenda. We're going to cover these things. This slide isn't terribly important. Besides, we're going to talk about MFA, a quick overview. We're not going to go into detail about what everything MFA has to offer and all the solutions and all that good stuff. We're just going to give a quick overview for everybody. And then we're going to walk through some war stories, some things we see in the wild, how you're probably not doing MFA as well as you think you might be. And then we're going to wrap things up in a neat, tidy little bow and send you on your way. So, overview. Hit the next. Multi-factor authentication. As I mentioned, we're not going to go into deeply what this is, but you should all pretty much have a good idea here. We had username and password. I know that's two things, but we call that single-factor authentication. So this is everything in addition to a username and password. So things like push notification on your cell phone, things like soft tokens, hard tokens. Up until pretty recently, SMS, but NIST kind of said, never mind, don't use SMS because of all the fun things you can do over SMS, like steal things. So anyway, we're down to a few of these. Now, you see certs on here with a question mark next to it, and the reason why it's got a question mark, raise of hands, who thinks certs are a viable multi-factor solution? Oh man, smart crowd. Okay, fine. Yeah, it's not. It's what we kind of term 1.5 factor solution, right? And why is that? Why are certs not as good as the other something else's? If you'll notice everything else in this list here, that's temporary. It's a one-time thing. It's a one-time PIN. It's a one-time passcode. It only exists for a little while. Hopefully a very short amount of time. Sometimes we see them exist for way longer than they should. But certificates, they're pretty permanent. Right? You can issue new ones, of course, and you do, but as far as permanence, someone can steal one off of somebody else's computer, put it on another computer, and you can pretty much gain the same level of access without too much trouble. MFA, the reason, one of the reasons we're having this talk, and I'll go into a couple more, it's hard to do. This isn't like something you just slap on and make sure and it works and everybody's happy. This is something that is difficult to do. You have to really balance the usability versus the security aspect. Like everything we do in our industry, you have to make that balance work. So you have to think about, hey, how often are we going to ask users to re-authenticate and use multi-factor? How often are we going to annoy them doing this? And are we going to use things like adaptive authentication? Things that might make this a little bit easier for the end user, but what are we losing as far as security goes when we use those types of things? So this isn't difficult. We're going to show you why it's not difficult, but let's talk about why we're here. So we're sort of past this, right?
Password. Password. Yes? No way. It can't be. Jesus Christ, that is just Babytown frolics.
Yeah, so we're sort of past that. I mean, that still works sometimes, right? But like most of the time it doesn't. So we've thought of, hey, how can we do this better? And it was multi-factor authentication. So we're still having this talk because I've made the bold prediction every year for the past 5 years that our red team and penetration testers would have a much more difficult time going from external to internal, and it simply hasn't been the case. We're having this talk because some people think a disaster recovery VPN means that you're not on the internal network. You definitely are. You're just in a different subnet, and we can move to other places. It's called lateral movement. It's one of those things in the kill chain. You've also told me, at least my clients have, that you've got a group of users Where multi-factor authentication, hey, it doesn't apply to them. It's too difficult for them to do. You know, it might be the C-suite where they're like, yeah, we can't bother them with an extra factor. Like, they're not going to do it. Or there's even the group of people who they say they don't have phones. And I don't know what to tell you. If you don't have a phone, I don't know. Anyway, really, what we're going to talk about are the next 5 or 6 things that Dan is going to go into much more detail about. And these are real-world scenarios. We've seen it with our red teams and penetration testing in how we either bypass, kind of sidestep, or otherwise just ignore the fact that there's multi-factor authentication out there and still gain access to internal networks. Cool. So the first up is email, and we're going to talk about email. And when our clients do multi-factor authentication, they multi-factor everything they consider to be a remote access portal. For some reason, people don't really lump email into the whole remote access portal thing. And it's because, I guess, it doesn't give you access to the internal network. It does, however, give you a lot of interesting access. So, Dan?
Sure. Like Chris was saying, we see email out there. They multi-factor all of the remote access portals, but email still hanging out there. Or they do put multi-factor on there, and then we'll kind of talk through a couple of different ways. Typically with this, we're going to talk about Office 365, OWA. If you're still using Lotus Notes, God help you.
I mean, it's still there, right? Like, some of you are still using it. Anybody, raise your hands, who's still using Lotus? Oh. Sorry, I'm really sorry. Stop by the booth. We'll give you one of those bottle openers so you can crack a beer later.
We'll pray for you.
Yeah.
And so our typical attack for these is once we identify sort of the the portal or the service, we'll do something like password spraying. So taking a bunch of usernames, writing a single password against this. But what we do see is this is rarely detected. I mean, it's difficult to detect based on some of the architectures that are in place. You know, sometimes you have your OWA server that's authenticating to your DC, and you're only getting DC auth logs, and so the source IP is always showing as it coming from the OWA server. So you're never getting that true source IP, so it's always a failed login from the OWA server. You're not ever seeing, we're getting tons of hits from this particular IP, but you're not seeing that because it's all the OWA server.
If you zone out for the rest of this talk, remember this one thing. Go back to whatever company you're from and configure a rule that detects when someone guesses like 1,000 passwords against your endpoints and then gets in. Just configure that rule, and everything will be a little bit better.
Cool. So the first thing we're going to talk about is OWA. This is Outlook's web access application. When we see this out there, it's typically fairly easy to identify. You can just sort of do some searches for subdomains like webmail. There's also the auto discover feature. If you're not familiar with it, you can sort of just plug it in, and it's what something like the Outlook client or some of the other services can use to identify the Exchange server. The other thing with this is not only do they have the web portal that's accessible, but you also have the backend services for Exchange to connect into. And the interesting thing with Exchange is there's a couple different mechanisms that you can use to connect to. So if you don't necessarily have access to that web portal, or if the web portal is multi-factored, don't forget to try and connect with different services, because you might be able to just connect to them over single factor. So we'll kind of walk through that. So the gist there is basically try to use like the Thick client for Outlook. That will use a different method to authenticate rather than just the portal. There's also tools like Ruler and Mail Sniper that will also connect directly to the service instead of going through that web portal. So here we have just like a quick screenshot. So this was an Outlook web access portal, and with this, it was behind something like an F5 device or some type of SSO to further, pass the user's access through. So with this, we see they have a username, and then in addition to the password, they have a passcode, which it makes it a multi-factor authentication for it. But the interesting thing was we did a password spray on a different portal, and we found a set of credentials that worked. We couldn't log into anything sensitive with that, so we tried just sticking it like the Thick client, and then you just pull down the entire user's inbox to your local system with the username and password. This would also help with, we do this with like mobile apps, so using Outlook on your phone or using like ActiveSync.
Yeah, so just multi-factoring the front end doesn't mean there's not another service listening that you can connect to.
Office 365. This is something that we're starting to see a lot of people starting to transition to. The Office 365 is pretty easy to identify if someone's actually using it or not. You can just go to any of the Office 365 logins, like portal.office or login.microsoft online, and all you have to do is just put in test at, whatever domain.com you want to check, and then you just hit tab down to the password field. And the nice thing with that is it will either redirect you to the actual URL for their login if they're doing something like ADFS, or it will just, pop in their logo on that Microsoft login page, and then from there you can just log in. You can do password sprays against that, and then this isn't necessarily saying, MFA is bad on this and a bypass for it. It's once you get access to Office 365, there's a lot of damage you can do, and we're starting to see a lot of people transition to Office 365, and they're like, well, we don't have a lot of users using it yet. Why do we need to multi-factor it? And so the next slide, using the PowerShell modules for Azure AD and MSOL, Microsoft Services Online, you can actually connect into an environment with the username and password. You can then pull down the entire user list. You can pull out cloud groups that are sent out through federated with Azure. You can pull those down, and then you don't only get like your initial 500 users that you did that password spray against. You get all let's say like 200,000 in the entire domain, or a couple of domains that are also federated out. So you get everything.
Yeah, this is. Yeah.
What was that?
Yeah, it's all.
No, this is authenticated. So you still have to authenticate with the username and password, but once you do, it's just like AD, querying it. So.
Yeah, you AD query this, and the point of this isn't that. So it's what Dan was saying. You started an Office 365 project, and you federated your domain out to O365, and you maybe have 3 users that can use it. But guess what? You can still log in. You federated all of your information with Office 365 at that point. And if you can get just one user, you can then dump the back end and get all the users. Now you're not getting passwords out of this, but again, you're going to go back and redo a password spray based on this information.
The other cool thing with this too is they don't necessarily have to have the mail service or the different apps for that user. Just because they have an account on here, that's all you need to go in and actually authenticate and query it. So we see that a lot too, where they're like, well, none of the accounts that you use have access to mail, or we don't have mail or Skype or something like that. And you don't need that. You can, authenticate to it and then pull the info out you want. And then there's the links to the modules if you want to try them out. So what do you do once you get access to someone's email? Because it's not the end. What you want to do is you want to start to pilfer for data. So things that you want to look for, you might find like M&A data for mergers and acquisitions. You might find a bunch of SSNs if you got into an HR person's email, credit cards, things like that. A lot of sensitive data just kind of sitting in files. The other thing you're going to want to do for it too is do searches for things like password, couple of multi-factor solutions, RSA, Duo, things like that, MFA, VPN. If you didn't find that VPN portal already, chances are there might be an email that has a direct link to it that you can then click on. And then there's a tool called Mail Sniper that actually helps with this process. So you just feed it credentials and then, specify, based off of what you specify, it'll go through and start to look for things like passwords, things like that, and then export it to a CSV file.
And you might get something like this.
So this is a good example of doing pilfering for that. So we did a search for RSA, and we found an RSA soft token that was, sent to the user. So we just downloaded that, stuck it in our VM, our attacker VM, and then connected to their VPN solution. Now, the interesting thing with the soft token is you still have to guess the PIN, at least for the way that this RSA was configured. You still have to guess a PIN that's assigned to that soft token, and so there was a nice email that was sent out before this that said, hey, the default's 9999, change that. So 1, 2, 3, 4 obviously worked.
Yeah. Of course.
And then the other thing too is, based on different talks I've had with people, this is something that might be new to them, but through Outlook you can actually get shells from systems too. So what you can do is you can go in and create a malicious form that's going to leverage something like a VBA, a malicious VBA file or code that then gets executed, and you would trigger that with a rule, or you can just configure a malicious rule, that executes on a certain given trigger, and then executes the code, and then you can get a remote shell that way.
So next up is one of my favorites, self-service. And sometimes self-service doesn't go exactly as you hoped it would go. You're giving your users a little bit of power here, and the reason why you're giving them some power is because self-service portals are designed to do what? They're designed to allow someone to reset their own password so they don't have to bother the help desk, because the help desk has other things to worry about besides password resets. And so that's why they're out there. It's to lessen the burden on your service desk or help desk, right? So this is an external service, and you should have MFA on this. But what happens when you don't have MFA on the thing that controls MFA? Well, then here's RSA self-service. We have picked on RSA twice. This isn't like just their problem. This is a lot of different ones. This just happens to be the example we were using.
Maybe this service shouldn't be exposed to the internet.
Yeah, maybe that. Maybe you should only be able to reset this when you're on the internal network. I don't know. There's a couple different ways to deal with this. But you enter a user ID here, then you get to the next screen, and you get a password prompt. And sometimes you can do a password spray against this, but sometimes you can't. You have to do your password spray somewhere else, and then you come back here, and then you can enter in the username and password. But Dan, please tell us how this works.
At least with the RSA ones, it's smart enough where it will sort of send you on to guess the security question for each user sometimes. So can't really do user enum through it, which is good. So the fun thing to do is Self-Service Portal. So once you gain access to it, there's a couple of different things you can do. You could register a new device like yours for their account. The only caveat with this is you usually have to have access to their email. So if you are able to gain access to their email, you can then go ahead and create a new device, which we'll sort of step through in the next scenario. The other fun thing you can do with this, and I know this is for RSA, I'm sure Duo or some other multi-factor solutions also have a similar feature, but these are emergency access tokens. There's a great blog post by Alex Leary from NetSpy on this, but basically what you can do with an emergency access token is if you can configure this through the portal, this is a code that you can then use to basically put in place of your regular the pin that cycles on your MFA solution.
It's a master code.
Like I was saying, you can go ahead and create a new device. So in this scenario, we were able to gain access to the self-service portal. We went through and said, hey, I want to create a new soft token, specified iPhone, and then you just have to create a PIN. The interesting thing about creating a PIN is it also tells you can't use a PIN that you previously used. So I haven't tried this yet, but based on that, it seems like you might be able to figure out what the user's previous PIN was.
And also notice it's only asking you to create a new one and confirm it. It doesn't care what your old one was. Like, we're back to like 5-10 years ago when people were just asking you to create new things without verifying the old thing. So that's probably a flaw that should be corrected.
Yep. And then there's just a field for reason for request. So for that, we just filled out and we said, hey, we got a new phone. I want to add this. The one thing I will say is it might be helpful to include what we have there as our binding ID. So if you download the RSA app on your phone, you just pop it open, and there's a binding ID that they need to create the token with. So it might be helpful to just include that in there. That way, when they go ahead and go through the whole process, it's already there. They don't have to contact the user to get it.
Yeah. So a bunch of things went wrong here, right, in order to pull off this type of attack. One, we were able to get into this portal. Two, we were able to register a new device that did not belong to the employee that originally, had these devices registered. And when we registered that new device, do you think that employee was notified that a new device got registered under their account? No, they weren't. They just had a new device, and they had no idea there was a new device in there unless they logged in and looked at the list of devices that existed.
Yep.
And then the process to actually get it approved in this case was automated. So basically, if you did this, it went through a queue, and the instructions for the service desk were, if you ever see these come in, just automatically approve them. That's somebody trying to get a new device on with their multi-factor authentication solution, and you're good to go. So there's a lot of steps here that kind of could have been stopped when we were doing this attack that just led us through and made it happen for us.
Mm-hmm. Yep, so we just got an email with the new URL string that we just download and pop in our phone, and then syncs with it, and we get our ID. What we did here, though, we created a mailbox rule that basically said if there's anything coming from RSA in like the subject line, just automatically mark it as red and send it to the deleted items, and we'll just check the deleted items for it so the user doesn't see it.
Right. Microsoft Remote App. Has anyone heard of this? Use it? Know what it is? I saw some yeses. Okay. So Microsoft Remote App is basically like Citrix. It's basically the same thing, only Microsoft produced it. We don't see this a ton, but we see it enough that we thought we should include it in these slides here. So basically what happens is you log into Microsoft Remote App. You have that nice pane of glass which displays all the applications you're allowed to connect to. Yeah, it looks like that. So you can access all the versions of IE you would ever need to access for whatever reason. And once you're in this, it's basically like having access to the internal network. So we're moving ahead a little from just, kind of identifying things that may get you access to the internal network to things that will get you access to the internal network.
Yep. So it's going to be similar to Citrix, and the user that you log in with is going to have access to the apps that they have published to them,
right,
or a remote desktop session, something like that. So the cool thing that we figured out with Remote App is you can stick this behind something like an SSO for multi-factor solution because it supports sort of pass-through auth from some other provider. Sending it through. And then you can also do direct MFA on it with something like a Duo plugin where it gets included with that sign-on from the actual web portal. The interesting thing that we found out with this is while that's all done on the website, sort of similar to the OWA scenario that we were talking about, if you can connect directly to the connection broker, you can log in directly with just your username and password, and it completely bypasses that SSO portal.
So what does that look like?
So Microsoft actually provided a slick tool or a client that will allow you to do this directly. So if you're running something like Windows 8, and I think up from there, we did this on Windows 10, but I believe it was in Windows 8, there you just open the control panel or your start menu and just search for Remote App, and it pops up this client, which you can then just paste in your email address or a URL to the remote app server that you want to give it to. And this will actually go against the service itself instead of going through that web portal. So you just log into it that way, and then you get the listing of applications just with username and password. And then you just pick the application you want to launch. It launches it in sort of an RDP session, but it's not a full RDP session. It's just the application spawning. So on the server, at that point, you just do your breakout, and you're on the internal network.
And this one was super easy. Dan mentioned you can enter an email address. I just want to make sure everybody caught that. That means you didn't even have to know where the service endpoint was. It auto-discovers, based on your email address and your domain, where the service endpoint is, and just connects you to it without the multi-factor portion.
Yeah.
Social engineering. Many uses in the red teaming and penetration testing world. And it's even more useful now for things like multi-factor authentication and bypassing multi-factor authentication. We've used over the years social engineering to break into buildings, to get just usernames and passwords, to get sensitive information from our clients. But in this case that Dan's going to walk you through, we're going to use this specifically to bypass their multi-factor authentication solution and gain access when we definitely shouldn't have access.
So social engineering is probably one of my favorite attacks to do. But so the scenario for this is the first thing you're going to want to do is start to perform some OSINT, some open source intel for a person that fits the role that you want to find or that you want to access. So with this, particularly targeting like a VPN or some type of remote access portal, I'll typically go through and be like, all right, so which type of employee is always going to be on the road? It's going to have access to these type of services. They might call the help desk a lot, and they might not be the best person to call the help desk because everyone at the help desk hates them. Salespeople. How many people have salespeople in their environment that use these remote solutions and always have issues? Sometimes you have to airdrop a laptop because it gets crypto wallet or something to a hotel. Yeah, it happens. I worked support before, so I know. Salespeople are usually a pain. So I try to find a salesperson, and then from there, get some info about them that I can call in with. The other thing you need to do is you need to find the help desk number. Sometimes this might just be as easy as being displayed on some type of, employee site that's externally facing. Sometimes you have to call a couple of numbers, so maybe try calling the reception desk at a couple of different offices, and sometimes they're nice enough just to pass you through or give you the actual number to call. So from there, once you obtain the number, calling into the service desk, and then what you have to do is get a password reset. Sometimes you actually need to get them to give you the proper username because it's not going to be first initial last name like you expect. Maybe it's, your full name, or maybe it's some random string of characters. So you might have to do that. You're then going to have to get a password reset, assuming that you don't already know the password. So getting a password reset, and then the icing on the cake, getting an MFA token reset. So you have a couple of things you have to do. But I will say, don't forget about the web-based chats that are out there. If you find a support site that has sort of like the instant message client, built into the web browser, don't forget about those. Sometimes they're actually easier to use than calling in. So I've discovered some helpful tips that sort of might aid you in social engineering. The first is play dumb, and when I say play dumb, I mean really dumb. Sort of the more frustrated you can get the help desk person, the better for you.
This is one of those like unethical life pro tips.
Yes. So basically, the service rep is going to want to get you off the phone as soon as possible, because they're usually, their performance is based on metrics, so how many tickets they get through in a given day or a given time period, something like that. So the quicker they get you off the phone, the quicker they can get to someone else. And like I was saying, the more frustrated, typically, the easier it is for you to get what you want. We did this one time, and one of our guys actually got this one lady so frustrated, she just stops and says, "Sir, it's a thinking problem. It's not an issue on our end." Which, sort of after that, she was more willing to sort of give us what we wanted.
You got the password.
Yeah. Don't get a guilty conscience when you do this.
Yeah.
It's fine. But like I was saying, this, using the instant message client. So this is an example of using the instant message client. Basically we said, hey, we're this user, we're a sales rep, we're trying to get access to some portal. We saw they were launching some portal. I think it was like Yammer or something, which was like completely unrelated. And we're like, we want to get access to the Yammer. And,
no one wants access to Yammer, by the way. Like, no one.
And like, this guy was a little confused at first, so we start walking him through, and we basically got him to tell us, oh, you're using the wrong username. So we're like, all right, cool. And then we're like, we still can't log in. And he's like, you on the VPN? We're like, no. And so he resets our password just to winter 2017. And then he's like, it's still not working. He's like, do you have, like, what's your credential ID for Semantic VIP? And so we just, like, pulled it up as we downloaded the app on our phone. And we put it there. And we didn't tell him to do this, but he just, like, coded that into the user's MFA for Semantic. And he's like, oh, try again now with the code on your phone. And it just works.
Yeah.
So
when you download that Semantic app, everybody gets, like, a unique ID, and he needed that. That just clarify.
Yeah.
Okay.
The one thing I will say is if you are going to do this, it's really helpful if you just go ahead and download, like, every multi-factor app out there so you have it already.
Yeah, just have it
like,
ready.
On your phone. So basically, we took this remote access portal, which was a Citrix portal, with a username, a password, and then the Semantic VIP token. And then from there, we had them reset everything for us, and we just logged in.
Yeah.
And the funny thing was, this didn't just work once. Like, we did this, and it worked like 6 times. So
it did. It did. Oh, shared MFA. This is my story time, isn't it? This picture will make sense in just a sec. So we were doing this test. This is probably one of my favorite stories from 2017. We were doing a test for a client, and we were hammering away on a single factor portal. And we were doing our 1,000 password guesses, 1 password guess per 1,000 users, as to not lock out. Anybody have some favorite passwords they like to use for any red teamers or pen testers? Yell it out. No? Summer 17, what was the other one? All right. They're all good. Anyway, we were using fall 2017 because, that one works probably more often than not. And we were getting some hits. And you know how when you're using, if you're an avid user of Burp Proxy, your length is all the same, and then all of a sudden it's not, and you get super excited, and you're like, oh man, we got one. So that happened like 5 times, and we were like, oh, this is spectacular. Let's go to the portal and log in. So we tried the first one, and it didn't work. We're like, that's weird. So we tried the second one. And the second one worked, and we were like, so excited, that's great, we got on. So we tried the rest of them, and they were like intermittently working. We like couldn't figure it out. So we were like, all right, whatever. So we'll just go with the first one. So we had like 3 of our testers log in and use the first one. And so we had 3 different connections going because we like to crowdsource our penetration testing. And we couldn't, we went through the whole thing. We got internal network access. We moved laterally, escalated privileges. We did the whole thing. And we wrote it up for the client, and we sent it to him, and the title of it was Single Factor Access to the Internal Network. And the client got the report and was like, guys, what are you talking about? We don't have single factor access. We upgraded everything to multi-factor access. This can't be right. And they're like, okay, well, what's the URL? Maybe we're using a backup or something. No, that's the URL. That's the right thing. And everybody's using our multi-factor solution. So, well, what is it? It's phone factor. Does anybody know what phone factor does? Phone factor calls you. Yeah, it calls you. And so what we found out was, this was in a hospital setting, which makes it a little bit more funny for all of us. The doctor used a cell phone that he registered with Phone Factor and crowdsourced his multi-factor authentication to his entire department. He basically said, if this phone rings, pick it up, press the number, and that's all you have to do. And so we couldn't figure out why this one was working every time. And we must have did it 15
we did it
times.
15 times.
At all times of the day and night. And so some intern at 2 a.m. was probably one click, hang up. So anyway, the moral of the story is don't crowdsource your multi-factor authentication. There's not much technically you could have done to prevent that except for it's a teachable moment. That's what we're here for. Teachable moments. Next, we want to make sure we touch on, of course, internal MFA. All those other examples were internet-facing multi-factor authentication. But as we move to more secure organizations and securing the stack, we want to focus on internal MFA as well. Why? You've got zones you want to protect. You've got a PCI zone. You might have HIPAA data in a certain zone or other really sensitive things that you might want to configure a jump box or some other type of configuration that prevents just normal users from accessing that zone. And a great way to do that is with multi-factor authentication, but it doesn't always go as planned. By the way, this is of the external ones. External isn't easy. This is even less easy. This is harder to do.
So the first thing we're going to talk about is remote desktop. So like Chris was saying, you might have some highly sensitive zone that's supposed to be segmented from the internal network. We see a lot of people moving to jump boxes to sort of be an intermediary between the two zones. So you jump to it. In this particular scenario, and we've seen this a couple of different places where they put something like RSA or Duo multi-factor on the actual remote desktop for an interactive login. So if you were to actually go up to a computer, it would also have it there for interactive logins. But for this case, it was remote desktop. So you launched the remote desktop session because we had a bunch of docs that we found that sort of had info on how to connect to the jump box, and we're like, okay. So we just pop a remote desktop session to it, and we're like, oh, okay, multi-factor makes sense. The weird thing was we're like, well, how does this communicate with the DC on our network? How does this get updates and things like that? And so we start looking into it, and we're like, oh, there's no firewall in front of this jump box to restrict ports or anything. So you can just still connect to it. Over your standard SMB, using RPC ports to sort of run WMIC or some other commands on it. And they still work with single factor. So this is sort of what it looks like. So we remote desktop in and we see this, but then we're like, okay, let's see if we can just run some commands on that remotely from our system, which is in Userland. And we see we can just run task list on that remote host with a username and password doing a run as, and we're like, oh, okay, interesting. So then we just get a shell on that system, without having to actually log into it. And from there, we just pivot from there into, their highly sensitive network.
Yeah.
So if you are going to do something like this, make sure you're actually creating something, that actually restricts users from using the services that, they can still access, which aren't necessarily multi-factored. All right, hypervisors. This is a bit of an interesting one. We see this at a few places, and it's a bit different. But basically, you have this highly sensitive zone. We'll say this client has done everything properly. They have, ACLs in front of everything. They're using an SSH jump box with, SSH key pairs in addition to their username and password to log into it. And then once you log into the jump box, you still have to go and configure a port forward session to, connect from your computer and push it through to whatever server you want to hit. So in this environment, we started to look around because we're like, all right, we're not going to find a direct way into it. So we started to look for the hypervisors and something like vCenter, vSphere, XenServer, something that's going to control things. So we started looking and we found this vSphere application that was accessible from the Userland. This wasn't on like a management network or anything. So we just hit this, and we were surprised to see that not only did it have sort of all the servers in that zone there, but you could just launch a remote console on it, and there was no login. There was already an open session on every single one of their servers. So at that point, you didn't even have to auth to it. It was a different domain, so we didn't have the credentials for it. But what we did have was, a server admin that logged into vSphere, and then there's an open session already on the server, so you can just do whatever you want at that point. Yeah. The moral of the story is, for this one, if you are going to manage stuff, from the same hypervisor, making sure that you're doing, some type of MFA on that, or you're segmenting the hypervisor access from the standard Userland. Okay. And then the last scenario that we have here is around dual NIC monitoring servers. And so when I say dual NIC, I mean something that has multiple network interfaces that are connected to different zones. And so for this, it's the same setup. We found this client had, properly done everything. And we were sort of looking around, getting access to different things just to sort of see what we could get access to. And we came across the Nagios server. Is anyone familiar with Nagios in here? Okay. So Nagios is, it's sort of a performance monitoring server. So, it can tell you when your CPU, on, X server is being pegged at like 100%. So it's like health monitoring for servers. And what we saw once we logged into this from the Userland was, hey, the PCI servers are listed in here. Does this have direct access to the PCI zone? And so, we basically did this. We said, all right, we'll log into this Nagios server, which was a Linux box, and then we just did a couple of discovery things to see if we could hit, PCI servers, and we could. So from there, we just did a port forward through our SSH session from our attacking workstation to the PCI SQL database, and from there, we're able to exfil credit cards. And the funny thing with this was, because we were not going through the standard jump box, we weren't going through the standard method that client had already configured for. This is how you access PCI. It completely bypassed all of their monitoring solutions. So they didn't get a single alert for all of this, the logins to the SQL server, because they're doing interactive logins to the actual system. So all of these connections directly to the SQL service weren't even, logged in their SIM.
Yeah. They weren't happy about this one.
Yeah. It was funny too, because we had been doing this all day, and it's like 7:30 at night and we're still there, and we see this and we're like, all right. And then we're waiting for someone to come down and like yell at us or get a phone call or something. And it never happened, and we're like, okay. So we told them about the next day, and like, we didn't see anything.
Yeah. So as promised, we're going to sum things up here. So you just saw Dan describe a bunch of different ways that you can either bypass multi-factor authentication, ignore multi-factor authentication. So 5 things to remember. MFA, all the things. What we mean by that is, don't, consider things like email not to be a remote access portal. You want to have multi-factor authentication on anything that might contain sensitive data, or allow an attacker to use that as a jumping off point. Great, you want to have people have access to email. That's spectacular. Put it behind the multi-factor authentication solution. You don't have to put MFA on the email itself. Put it behind the portal that you've already configured to have MFA. Test your service desk. Your service desk has a script, and they're going to follow that script. And if the script says automatically approve all these requests that come through, guess what they're going to do? Automatically approve all those requests that come through. The most important thing here that we see throughout these tests is that there's not a proper method that a service desk can use to verify that you are who you say you are. It seems like it's disparate. Nobody really has that, like, nailed down 3 things that they need to ask in order to identify somebody is who they say they are. And you have to make sure that those pieces of information can't be easily gleaned from other sources, like LinkedIn, Facebook, etc., things that are already on the internet, or hey, what's your username? Like, I can figure out the username. It's not going to be difficult. If you go to like email-format.com, like that tells us your email format, and then it also tells you the username scheme, the probable one. So make sure you test that process start to finish and see if there's any areas for improvement there. And test your self-service portal. walk through it yourself. Walk through it and see, is there any point in this self-service portal setup in which an attacker who isn't me could simply inject a new device in and gain access and pretend to be me? 3 is super important. It's around monitoring. A lot of these things could have been detected. I'm not going to say prevented necessarily, but definitely detected with proper logs, going to a SIM or doing threat hunting with EDR solutions. These types of activities are super important. You're not going to get everything to be perfect. It is still 2017, and the purpose of this talk wasn't to say your MFA should be perfect now. These are some of the things to think about, but also do lots of monitoring to find out what the bad guys are doing on your network. Expire OTPs, I mentioned earlier, we see a lot of these last way too long. They sit in email. We can pull them out once we get into email and just use them as a one-time pin. In particular, those registration emails to get set up for the first time, make sure those expire. And last but not least, for everybody in this room, makes sense, think like an attacker. Walk through all these processes as a penetration tester or red teamer would, or bring in somebody to help you do that that's done it lots and lots before. They'll help you identify the gaps, shore up the solution, and make things go a little bit better when you're implementing your multi-factor authentication solution.
Yeah. Like Chris was saying, when you're implementing these, try to think about the other things, like the services where you're sticking an SSO in front of it and you're like, oh, it's multi-factor. But then you have these services that you can just directly access, from the internet. So the scenarios that we walked through, they worked for us. Your mileage may vary, of course. And, these were just with different configurations. So you can actually, do it properly. It's just making sure that your config actually makes sense and, you're restricting things that you should.
So thanks all. We'll take questions if there are any. Yeah? 2 questions. So I think the question was, and correct me if I'm wrong, have we tried attacking Windows 10 with the picture and pin login? Sure. I mean, if you're using the pin, it's just a bunch of numbers, and then eventually it'll lock you out. We haven't done extensive testing to see if that's like, a flaw that Microsoft has in their, authentication scheme. But if you're using something other than the password, a picture, I'm sure there's lots of folks who've done research to tell whether or not that's good enough. You've got the fun Apple stuff now that's way more advanced than anything I think Microsoft had come out with when they thought about doing those picture things.
Yeah, we also don't see that rolled out in the enterprise that much. It's still
very rare. I don't think I've ever seen it in an enterprise environment. Yeah, it's a good question. And he said, some of these things were just one additional factor. What about more factors on top of that? I think as you saw with some of the examples, and particularly the ways we sidestep all multi-factor authentication, those are still applicable. You could put 7 layers of multi-factor on there, but if we're not using it at all and we're just going in a different direction, we're stepping around the landmine, it's not going to matter how many layers you have. Any other questions? Questions. All right, well, thanks all.
Cool. Yep. If you do have questions, we'll be walking around later, so feel free to stop us.